Well, good day. Today we're going to continue with our discussions on the Module 1 for our course. And today's lecture will cover authorship, which is the second part of Module 1, Lecture 3. So you'll see that I'm beginning to post lectures based upon that, as indicated from the syllabus. Before getting on to the Module 1, Lecture 3-2, I want to go to the MyWebCT and just show a little bit about how the case studies are being posted as an example, and then how they are tracked and added to, and then we'll go to the textbook just for a moment to make a few points, and then return to the PowerPoint slide presentation for this lecture. So let me take us to the computer. Sorry. There we go, that's better. Trying to eliminate the scan conversion so that in the classroom here it looks better than for the recording. So when you get to the MyWebCT, of course, oh, mine disappeared because I clicked on it already. Anyway, there was a little push button pin there under our course that would take me right to the discussions, but because I clicked on it just a moment ago, it's not there anymore. So if one of those appears, then it will take you straight to the communication and the case study discussions as shown on this page that most of you are familiar with now. And it's the main that we're working with here. So when you compose and post, make sure you add it to the main, and that of course is, as some of you have seen already, just let it go to the default right there at that setting. You'll notice when I go to the list that Steve has used kind of a long title, so it gets truncated when it shows up. What we can do is just use CS for case study, and that'll shorten it some so that people can have their name there. So when I click on the main under topics, we see the first two that I had posted, and then there's others that posted, and I'm not really sure how these threads got broken up. Those are the case studies A1 and A2 that are listed under that icon on the home page, and I hadn't intended for them to come onto here, but that's fine. So Stephen has posted two of them, as you can see, and we'll go to those in a moment. I just viewed these before it showed that I had read that there was one unread out of 9 responses, and on this one there was an 8 there. 8 that I hadn't looked at out of 9, so it gives you some input. So there's 1 out of 1 that has not been viewed in this case here. So let's go to this first one here that has 9 in it. Somehow on this one, I had to post it twice so that the attachment would be there because I didn't get it attached the first time. And all of the responses, so I have everybody's name on there, so I can make a list of names of the people that participated, and then with that list send an email to everyone in the class and say these people have responded to my case study posting. The rest of you haven't. If you haven't already, please log on and and provide your input. So that's one way that we can contribute to the oversight of our own case studies online. In addition, we can reply, and my understanding is that when we click on the reply here, it all stays within the thread so that all the input on a particular case study can be viewed just by clicking this one. So I don't know how case study A2 and A2 got into 3 separate ones here. I don't know if those individuals posted them separately or whatever, but let me go into Steve's first one here and try a reply. Good job. I have nothing to add. Loser. Obviously, you can't get away with that. And so now if we refresh this, update listing, so it shows that there's 2 with 1 unread in this now, and there's my, and my name is there, so you know who loser is. So that's the way that we want to continue with these. I'll go back to the home page, to the calendar, to show that Steve, so Nyan, close enough pronunciation, my apologies. You posted the case study 1 then that we saw. Okay. So what we want to do in addition is put our name there so that we know who's responsible for posting it. Okay.
Custom said it hasn't showed on the discussion. Maybe I will have to post it again on the day 22nd.
Yeah, and I'm not sure if we can go in and edit these once we've got them posted. But we don't need to worry about it for now. I think we'll just develop a model as we go along, and we'll see it, and there'll be an ultimate one that we'll be using throughout, I guess. And you're not allowed to be as bad and inattentive as I have been to your case studies. You got to get on there and take care of them. So next, I just want to go to the document camera for just a moment to give us a reminder that I don't generate all the lecture PowerPoint presentations straight from the textbook, but obviously there is information material in the textbook on everything that we are covering. So the quizzes can come from lecture and reading assigned materials. So I'll be looking at lecture content and textbook content for generating the quiz questions on each of them. Again, it doesn't generate a grade for you. It's a good feeling and generates a little more self-respect when you score well on a quiz versus getting a 2% on a quiz and saying, yes, I did view the lecture. So, so far we have certainly covered Chapter 1 and Chapter 2, the collection, analysis, and management of data. Some of the content we might be coming back to at another time. Today we're dealing with authorship. Resource sharing and mentoring will come at another time. I do want to just switch to a page at the end of the chapter on collaboration and research to point out a distinction between the discussion on authorship that we're talking about today and relevant information from the textbook that has something to do with it. And the reason that I want to go to this at this time is to call from our early lectures that science and research is a social commitment because there is so much, and a social responsibility because there is so much collaboration. And we enter into collaborations more readily than what we might think. And quite often we enter into collaborations without establishing exactly how the collaboration would be structured from the very beginning, and it can lead to problems. And you notice the first thing that they list here is authorship. Who will be an author? Who will be a second author? So very early in the initiation of a collaboration, this has to be established. There would be sometimes a very natural falling into place of the research roles and responsibilities. It can be different at other times. So you have to make a careful evaluation of this before, if you can anticipate it, but definitely very early if you don't anticipate it and find yourself in a collaborative environment and are developing that over time. The extent of the collaboration, how long might it go into the future, how short might it be, intellectual property, sometimes you can't anticipate or predict what intellectual property might emerge and what the value might be. Certainly funding, Sometimes there are collaborators who simply provide the funding and don't get too much involved. Other than that, that's, I think, the rare situation, but it is not uncommon. And certainly conflicts of interest. And this is a difficult one because the assumption that you make going into a professional arrangement like that is that everyone has completed their form. Oops, there's a couple more here. Their form that should be required by their institution for their claims on their potential or lack of conflicts of interest. You're not going to sit down to everyone and go, do you have a conflict of interest? Do you? That may emerge over time, but there's this assumption that professionals meet their responsibilities, so quite often that would not come up. Now, if the work is obviously going to be related to some procedure or outcome that could be patentable and licensed and generate revenue, I think these would be essential matters that had to be taken care of and documented appropriately. Could be in the notebook, as we had talked about before. So the dissemination of the results, how would they be disseminated? Abstracts, research reports, who's committed from their own contribution to including something in one of their reports for their funded portion or component of it, and so on and so forth. Deadlines is important, setting tentative deadlines, final deadlines. It's very difficult to do, especially if the collaboration is one that extends over many miles. And regulations, certainly, the approval of animals in human research, approval of humans as research subjects, and the IACUC for animals, and all the biosafety and radiation safety requirements. So those are essential and are actually the pretense, if you will, to finally reaching the point of publishing a paper and considering what would be required for authorship and all that is associated with that, as we will discuss in this continuation of the Module 1, Lecture 3, Reporting, Research, and Authorship. So in this one, we're talking about the authorship specifically, and we start first with this publication from the Journal of Neuroscience. The neurobiology doctoral program was the first emphasis in the PhD program at UTSA, so this showed up first. You can see the year 1999, but we'll leave it in there out of respect. Certainly all the comments made apply across the board for any discipline. But we can use this as somewhat of an example for, or to draw an analogy, is that these are parts of a code of ethics for the neuroscientists. The Journal of Neuroscience is published by the Society of Neuroscience. It's an international society. Is that a conflict of interest in and of itself? We don't know. But anyway. Regardless of that, this is a publication for a professional society, so is it then a code of ethics? It certainly is a set of guidelines for considering the behavior. Writing is a behavior, if you want to think of it that way. Thinking is a behavior, if you want to think of it that way. Sitting still to think hard is almost as difficult a behavior as running a marathon. So the Society for Neuroscience states its premises that the progress in understanding the nervous system benefits human welfare. So can't argue that. Nice global goal as a source of generating objectives for a professional research society. That progress, of course, depends upon virtue of honesty. An individual who contains or has developed within themselves and continues to display the virtue of honesty is an honest person. So we can kind of work in our basic concepts here as we proceed. And I think honesty was definitely one of the virtues on the list that we went through. So the honest pursuit of the scientific research and the truthful representation of findings. So truthfulness is the virtue, and truthful is the adjective, of course, that would represent that virtue in the individual that practices truthful representation of the findings. So there's a lot that is encompassed by that virtue of truthfulness for data to be truthful, and of course that's what we'll talk about when we proceed through our series of lectures on experimental designs. So here we see 1.1, 1.2, 1.3 under the main heading 1, authors of research manuscripts. So this is codified. So this is a code of ethics for the ethical the ethical conduct of publishing a manuscript. So the authors are encouraged to have the first formal publication of their results in a peer-reviewed paper. So rather than going straight to the newspaper and having it all show up on CNN or even local news before it goes through peer review is considered irresponsible and unethical, because only the authors, the originators of the data would be represented in that publicity or publicizing of the research. And this is especially important if the public tax dollars, either state or federal, or even donors through private funding agencies, are represented within the support for the data that is reaching the general media. So, being responsible extends to that part of it. Manuscripts should be prepared to maximize clarity and accuracy of communication. Authorship should be based on a substantial intellectual contribution. So manuscripts are written according to certain guidelines and procedural instructions, basically the instructions to authors for each journal, peer-reviewed journal, are posted. All of them now, of course, have websites, and the instructions to authors are posted there. So beyond meeting that minimum of having it structured properly, you have to put forth the effort to use language as thoroughly and completely as possible and correctly, and the statements must accurately represent the context of the report. And this accuracy comes through as well related to our continuum of zero association to 100% association, the causal association. So if you're claiming causality and your data does not support that, then it is an inaccurate communication of the interpretation of the results. So authorship should be based on substantial intellectual contribution. And this is where the debate comes in. What truly is, and we don't argue about intellectual, but what is the substantial? What's the substance of the contribution of each author to earn their authorship? So we can talk about a few, and there are additional ones defined in the textbook. Honorary authorship is inconsistent with the definition of authorship. There's a few others, as I had mentioned, from the textbook. I'll just try to flip to those pages here really quickly and run through the list of those. And I go to the document camera because we've got it. So there's gift authorship, honorary authorship, prestige authorship, ghost authorship. Publishing papers with the standard for the least publishable unit is another concept all of its own, but does reflect on the ethics and the character of the researchers, the authors themselves. There is a separate dedication of space to acknowledgments. So this is where there's the opportunity to acknowledge assistance that does not warrant authorship, but does merit recognition. So determining what merits recognition, the criteria and standards for this are not quite as well delineated. They're pretty obvious, though. If somebody helps out somewhere along the way, then they are due the credit for their contribution at whatever level. And before we go on to the comment on financial contributions, you'll find that some journals are requiring as basically addenda to the article or within the acknowledgments, clear statements of the actual contribution of each author to the data set that is there, or collectively to the research project that gave rise to the publication. Some even will have photographs of the authors in the addenda to the paper as well. So you download the paper and go to the last page, and there's the pictures of the authors with a short biographical sketch of each of them. So different professional societies or professions in science have slightly different standards and practices, but there is a common, unified, final set of expectations that are minimal. And again, we don't strive to satisfy minimal expectations and requirements. We're supposed to strive to exceed those. Financial contributions to the work being reported should be clearly acknowledged, as should any potential conflict of interest. This is kind of an interesting one. It typically happens, of course, in the background with some type of formal paperwork that is signed with the publishers. But again, it is assumed in the context of science as a profession. But there are cases where there could be some type of conflict of interest, and not so much for conflict of interest, but certainly as a disclaimer, if you read a research article published by someone that was funded by the Department of Defense or works for the Department of Defense, you'll see a long disclaimer statement that is standard in each of those, and I encourage you to look for them when you're reading through the literature. So 1.7, methods and materials should be described in sufficient detail to permit evaluation and replication. This is really difficult to achieve. You don't want to use all your space because it is limited and costly just to your methods, but what is provided should be sufficient enough to achieve this. Many people will give a brief description of the methods and then refer to a prior publication. That's acceptable, but sometimes very frustrating, although we don't necessarily have to write to minimize frustration of the reader at all times. Unique and propagatable research materials should used in the studies being reported must be made available to qualified scientists for bona fide research purposes. So this is part of that public property, if you will, public dollars contributing for the production of certain things, so they should be made available to everyone. That's a difficult one to police. It's more of stating it, codifying it, and place it in public view as an expected standard of behavior. We're always free to contact the authors that report the development or the production of something and ask for some of that or the idea or the circuitry, whatever it would be, as a gift. And we're either going to get a yes or a no as an answer. So, this is the approach to this level of the professionalism. Authors have an obligation to correct errors promptly. So there are quite often errata, E-R-R-A-T-A, I think that's Latin, published at the ends of issues of, on the back pages of issues of the volumes of journals. Prior publication, they're publishing the errata. If you go to PubMed, for example, as a search engine, you will find if you pull up a paper where an erratum has been published, it will list that, and the link to that will be provided as well. So these are key interlaced components for publication. Withdrawals are another thing, and those appear when an original research article has been withdrawn for one reason or another, and that's quite an interesting aspect to look for case studies as well. So what does an author's retraction contain when their publication came out in any journal, but especially a premier journal, and there's a lot of publicity about it, and then all of a sudden the scientific community in general starts expressing concern in letters to the editor or just direct communication to the editor or the authors or the funding agency, and then the scientists themselves jump into their record books and make the determination that there's been an error so substantial that they have to retract the publication and announce what the error was and the potential source. And then, of course, there may or may not be any additional action taken other than that mere sanction of quite embarrassing public display of admission of the error. So in science, it's essential that other researchers be able to evaluate and, if they wish, to replicate published observation. This enables researchers to build on the work of others, of each other, thus permitting the efficient use of resources. We said that replication was one of the criteria for establishing causal association. So, if you attempt to replicate someone else's work, and it can be justified, sometimes you have to establish that in your hands you can produce baseline data and then proceed with the experiment as you may have proposed it to extend that work. So you may try to replicate what other individuals have done, and the research article and correspondence are the primary means of accomplishing that. If you can't, then there's a very interesting dilemma that emerges. So a research article should contain sufficient detail and reference to public sources of information in a format appropriate to the journal style and policy to allow a knowledgeable scientist to evaluate and replicate the work reported. So all the sources of the ideas to put the method together, and of course all the sources of the reagents are supposed to be provided in as much detail as possible, required and allowed by the publishers. So the source of all materials and significant items, equipment, have to be clearly indicated, and that includes those that are not commercially available. So if it was an antibody that was generated or a chemical that was generated by a member of the research group or through gift from some other research group, that has to be stated in the methods and certainly acknowledged where appropriate. Any known unusual hazards inherent in the chemicals, equipment, and procedures used in an investigation should be clearly identified in the manuscript reporting the work. And this is, a very curious requirement as well. I read quite a few research articles. I don't recall ever seeing a statement such as this in a research article. So this is an interesting new thing that is added. And definitely I see the responsibility. I don't see an accountability, but I certainly do see a standard for responsibility in this, although no one should be just jumping into using any reagents or approaches without prior approval. So the institution and the individual bears some burden for this as well. Again, with publication, what we are battling is the precious resources of space for the production of the publication. Printing costs are quite extensive, as well as the cost for generating the PDF, the electronic files, and for posting them and hosting the websites and so on and so forth. So the size of a publication is a serious consideration in that context. So all the components of a research article should be subjected to peer review. We have a separate lecture on plagiarism. Obviously it is unacceptable. Fabrication and falsification, absolutely unacceptable. And each of these punishable by the ethical sanctions and by law. All data should be presented to minimize the possibility of misinterpretation. So misrepresentation of your data such that it might be misinterpreted, or indeed direct misinterpretation of your data, is unacceptable, and the authors are responsible for such acts. Some might be by oversight, and can be excusable, but never acceptable. So the authors should not engage in fragmented or duplicate publication. So the fragmented has to do with that least publishable unit. So what is the least publishable unit? If a person takes all of their collective work and puts it out in the smallest unit possible, the claim, of course, is that you're stuffing your curriculum vitae or your CV without being responsible to the general population for reporting complete experiments in reasonable space and context. So serving oneself more so than serving the general public. So that sounds like consequentialism there, a little bit of utilitarianism tossed in. So the informal communication of results and ideas is encouraged. Authors should not make personal attacks on other researchers. It is unprofessional to make personal attacks, as we have talked about before. But in the text of a research report, publication such as this especially, or any other kind, never should make a personal attack on another researcher or research group. It can be phrased in such a way to challenge what others may have done. You challenge your data doesn't support their hypothesis, or you failed to replicate their work, and a variety of things like that. We know that some scientists and research groups don't communicate with each other directly, so direct communication is never going to happen. We certainly question the ethics of such behavior, but we can't deny that it is and will continue to happen, is happening and will continue to happen. So the author should not discuss with reviewers any aspect of the manuscript under evaluation. So it is anonymous review. The reviewers are rarely identified. There's a lot of controversy about this, but still it is the standard. The anonymity of the reviewers is confidential and must be protected at all times. Therefore, it should be impossible to contact them, because they should never identify themselves, and no one should ever identify them to the author. So therefore, this should not even be possible, but it does become possible, and it's the author's responsibility and the reviewer's responsibility not to discuss manuscripts, and it stands for grant proposals too under review. Accounts of a researcher's publication record should be accurate, so no misrepresentation of oneself or their data is allowed at all. So each author, the guidelines for authorship have a few principles. The first principle, each author should have participated sufficiently in the work represented by the article to take public responsibility for the content. So this is the overriding principle. We'll get more specific as we go along, but the overriding principle is this, that you have to be responsible and accountable, at least for your contribution in the report. So if you contributed just one data set that produced one graph, one statistical analysis, and one set of conclusions, you are directly accountable for that, but you're responsible for the accountability for the entire content of the publication if you are a co-author. So the public responsible, and of course being responsible for your own contribution, therefore builds the honesty, reliability, and trustworthiness amongst all of the collaborators, so that the others can feel comfortable in being responsible for your contribution, your content within the publication. The public responsibility means that an author can defend the content of the article, including the data and other evidence, and the conclusions based upon them. Well, the simple skills that we've been developing so far and will continue to develop on this, the conclusions based upon the data, should allow anyone to defend the conclusions within a publication or to criticize them, be critical of them. And that should be part of the writing and the review and revision process among the authors. We should feel comfortable challenging the conclusions made by another individual at all times. We are always on guard as professional scientists and always the devil's advocate. If you ask the question and generate the challenge before an external reviewer does, then you resolve the issue before it even reaches that point. Being responsible for all the data and other evidence within an article, if you've only contributed a small part of it, is at the fringe of being unreasonable. If your area of expertise, say you designed and developed all of the chemicals that are being used, so you're the organic chemist, and someone else is doing cardiovascular physiology, testing all of those at a high level of sophistication, how can you be responsible for every single data point that was included in the publication? So there has to be a limit of reason on this first one. Whatever you contribute, you are responsible for and accountable for, and to whatever degree you have the expertise to accept such responsibility, even though it is a passive acceptance of that, active because you agree to be a co-author, but it is passive in the sense of being imposed externally, then you are accountable to that degree of expertise that you have. So also be willing to, so in other words, if you're an organic chemist or pharmaceutical expert that has, through your career, designed drugs to affect the cardiovascular system, over your career, you should gain some level of expertise in cardiovascular physiology and pathology if that's the desire for the use of the drugs that you're generating. So there's that type of expectation. So also to be willing to concede publicly errors of fact and interpretation discovered after publication, and to state the reasons for the error. So, this is that aspect of ethics that we talked about where it's different from law. You have to accept the ethical sanctions, which is public display in a negative context, the shame, the embarrassment, and then having the internal fortitude and resolve to overcome that and sustain your professional career, still be able to go to meetings, get up and present data. Imagine that first time you stand at a podium at a meeting with several hundred people in the auditorium, and you're going to present new data just a few weeks after your retraction on your last major paper was published. How tense of a situation that would be. You question your credibility in the presence of that audience. You know that the word is spread quickly among your peers, so there you stand and you've got to present some new data, and how do you open it? This data, I swear to you, is true. We're very careful in our record keeping and all that. So this, I think, is where we begin to see these sanctions, these ethical sanctions, have true impact on the professional scientist. After going through that type of a situation that we just described, you can bet that that scientist is going to check and double check and have a very compliant laboratory before any publication, manuscript for publication even begins to be written. So the accountability for the nature and the extent of deception, if fraudulent, is an assumed responsibility that we've discussed as well. So the nature and extent of deception means that there's some room for determining what extent of harm there may have been. Remember, we said that harm is when we suspect harm, then we invoke the principle of non-maleficence. When the principle of non-maleficence is invoked, we assess the degree of harm and the severity, the intent, the motivation, and all of that. And this is when the standards of ethics overlap law, and there might be legal action that could be justified. So if it was an intentional deception that reached the extent of proposing the utilization of a new therapeutic procedure, surgical, chemical, whatever it may be, for all human patients that fit the description, the medical indications, then somebody's in really big trouble, and at least should have some type of a fine and hopefully be fired and expunged from the profession, but it doesn't always happen that way. But there's room for flexibility. So not exactly a deontological approach to determining the punishments there. Participation must include 3 steps. Principle 2. So the conception or design of the work represented by the article, or analysis and interpretation of the data, or both. Drafting the article or revising it critically for critically important content, and the final approval of the version to be published. So here are some of the basic aspects of that. We'll discuss that more in just a moment when we go on to another list of criteria from another source. So principle 3, the participation solely in the collection of data or other evidence does not justify authorship. So first we define what is inclusive for authorship, and then make the opposite statement of what is exclusive for authorship. So simply collecting data does not, or other evidence does not justify authorship. There has to be more than that. So we'll extend our discussions of each of these as we proceed. Each part of the content of an article, critical to its main conclusions, and each step in the work that led to its publication, steps 1, 2, and 3, and principle 2, must be attributable to at least one author. So there has to be major contributors and minor contributors. And we'll see these stated a bit more specifically, as I said, and discuss them a bit more. So persons who have contributed intellectually to the article but whose contributions do not justify authorship may be named and their contribution described, for example, advice, critical review of the study, proposal, data collection. Such persons must have given their permission to be named, and the technical help must be acknowledged in a separate paragraph. So there's different degrees of acknowledgement of contribution. There are other professionals, the practicing scientists, and then there can be technical assistance that is acknowledged as well, down to the level of acknowledging the individual that did the typing at the computer, secretary or administrative assistant. Well, now let's turn to another source, experimental brain research, the instructions to authors, to look at how they state the prerequisites for a publication, in other words, authorship. So they subscribe to recommendations formulated by the International Committee of Medical Journal Editors. This is the source of that. So as early as 1988, these codifications have been considered and delineated. There's been slight modifications as we've reached modern times, but they're virtually unchanged. So accordingly, each person listed as an author or co-author for a submitted report must meet all of 3 criteria. So this is being much more specific. So an author or co-author shall have conceived, planned, and performed the work leading to the report, or interpreted the evidence presented, or both. So this "or," the grammar is important here. "Or" is very important. So not all authors may have conceived, planned, and performed the work leading to the report. If not, they should have at least interpreted the evidence that is presented. If you didn't have "or" in here, then the PI that is not at the bench, because they have the funding for a large technical staff and set of trainees to generate the data, would be possibly excluded as far as satisfying this, performing the work. Certainly involved in conceiving and planning. Written the report or reviewed successive versions and shared in the revisions. So again, this "or" is a very important term in here. There might be one person, say a doctoral student writing their dissertation, doing all the writing, writing the publication of their dissertation research, doing all of the writing at the computer, coming up with the first version, and typing it in and printing it out, distributing it. And the others would be involved, the other authors would be involved in reviewing it. There should certainly be more than one version, and each share in their contribution, each author share in their contribution to the revisions, and then give approval of the final version. So there has to be equal distribution of each version and sharing of all the comments and criticisms and suggestions and recommendations among the entire collective group. So this is the expectation. Is there any way to police how that is accomplished and how readily groups of researchers, authors comply with that? We don't really know beforehand. But certainly there is afterward. If a problem arises, then everybody's responsible and accountable to some degree or another. So if all members are not involved in their writing and revisions, then there can be some problems. So meeting these criteria should provide each author sufficient knowledge of and participation in the work that he or she can accept the public responsibility for in the report. So how this is accomplished is that there is a transfer of copyright agreement or certification in copyright. So in the transmittal letter accompanying a submitted manuscript, the senior or corresponding author is requested to certify that all listed authors qualify for authorship according to the above 3 criteria. So here we see that if we use this as a minimum, 3 of these, it is possible for every author to satisfy all 3 of these requirements, at least having been involved in the interpretation of the data, maybe coming in after the conception and the planning, maybe not being at the bench to collect the data, but the tabular and graphical and statistical evaluation of the data, and then trying to draw conclusions from it, making sure that it's consistent with the experimental designs as they were proposed and executed, and evaluating the conclusions and the interpretations so the interpretations are not overextended. We've talked about that before, claiming causal association when indeed it doesn't truly exist. So those are heavy responsibilities beyond just getting the numbers from the experiments at the bench. I'm not trying to minimize the work at the bench, but as we saw, if someone simply collects the data and turns it over to someone else, that doesn't qualify for authorship. There has to be some other contribution along these lines to satisfy number 1, and number 2 and number 3 are a bit easier to achieve. So really this first criterion is the most substantial one. And any modifications or additions beyond these certainly just create more extensive evaluations of everybody's contributions and qualifications as an author, but I think these three are the minimum. Satisfying at least these three should qualify an individual to be an author. And then the next question is, what is the sequencing of authorship? So who's first and who's 100th? There are some publications coming out now where the list of authors is so long, it just doesn't make any sense. How can 20 or 30 people contribute substantially to a 5-page report or even a 10-page report? So there's very interesting things that are occurring. Not all papers that have extensive numbers of authors fall into that category that I just mentioned. For example, there's a group that worked to discover the Huntington's disease gene, the HD gene, and the list of authors was not even included. They were just named themselves collectively as a group, and that was the authorship. So I think it is possible to have many contributors, but it certainly does make does cause concern for one to wonder. So the designation of the first author and the sequence of listings are important for several reasons. Some landmark studies known by the name of the first author being listed first, he or she played a pivotal role in performing the work and writing the article. So the first author definitely has to satisfy really everything in the first criterion and has to be the person that writes it, puts the words to paper or computer by the second criterion, and there should be no other justification for giving someone first authorship other than that extent and degree of substantial contribution. So it is that pivotal role. May not be putting the word to the computer, but putting the word to paper so that somebody types it for them, an admin assistant or secretary, doesn't really matter. The words have to come from the brain of that individual, and the effort to take into account all the author's contributions for revisions in their own words or representing those contributors' words is a substantial effort. So by tradition, many reserve the position of the last author for the senior member of the research team or the department or the division director. And this encourages that honorary authorship that we had mentioned, but still it doesn't change the fact that as we go through our research career, we may find ourselves having fewer and fewer publications where we're the first author, and we actually become the last author because we are the senior scientist in the group with the funding and the overall responsibility for the research and the report. But there's many variations on this theme. Sometimes the last author is the person that contributed the least, and the senior author is the second author. So there are different standards, and it certainly simply comes down to familiarity with the literature, with the individuals who are the contributing authors. So if you recognize a really productive individual within a discipline, you've been following their publications for a long period of time, when their name begins showing up last on many papers, then of course you recognize that individual as the senior author and now is probably training or collaborating with many other individuals. You may reach that point of honor, I guess, whatever it would be, but then get into a collaboration where admittedly, and going into it, the new collaborator is a more senior research scientist, so you take the second to the last position on authorship, or you shift to the second authorship, and this new senior scientist takes the last position. So, what are the guidelines? Everybody has suggestions and recommendations, and this, of course, is why some journals are going in the direction of requiring clear statements of who contributed what and to what extent individuals can be held responsible more globally for the entire content. I've had students that have gone off to other institutions for professional training, and they gain research experience, and before even an abstract for a meeting is submitted, they're reminded that the department chairperson always has last authorship on the presentations. In the one case that I'm recalling at the moment, this was a rather large meeting with, prestigious meeting with many of the national and world experts that attended. The paper, the abstract that was submitted, was accepted for platform presentation. When the department chair heard that, bumped the student as the presenting author and went and presented the paper as the senior presenter. Anyway, a lot of those kind of things can happen, and you always have to ask yourself what you would do in that situation. And this individual just stepped back and allowed it to happen, and has quite a successful career right now, but certainly would like to have gone on to do that presentation on their own. Anyway, that's an example of an honorary authorship, or maybe one of the others that we'd listed that can extend to more severe ethical dilemmas. Division director. So there, in some conditions, there's requirement to include authors that may not satisfy all three, and of course this is the ethical dilemma that we face in our profession, and we're constantly trying to clean it up, but it may never go away. So the responsibility falls upon the reader as far as gaining some appreciation for who among the co-authors, the list of authors, really are the contributing scientists, and to follow up on the work, their publications, their other publications of each of the authors, to make that assessment on our own. When I started my research career and submitted grant applications, I listed some of the major publications from my PI, my mentor's research group, on which some of them I was second author or third author, and just starting as an independent PI, was relying on those publications to demonstrate that I had the capabilities of doing what I was proposing, and the reviewers' comments came back saying the contribution can't be assessed from the co-authorship on these publications. So they doubted whether I could do something because I wasn't the first author on some of the key publications of our research group, and that was horrifying, especially when you've got preliminary data showing that you can do it and things like that. Just get you going. But anyway, you survive it and move on. So the first listed author versus, say, the sixth on a major article can carry substantial weight in the attainment of those academic rewards to which the investigators might aspire. And this is extremely important. You'll find yourself being evaluated and yourself evaluating others when you get their CV or your CV is being produced. Always count the number of publications on which this individual was first author, and how many is second author or way on out there. But first thing you look at is how many publications throughout the career which this individual was first author, and then is there a progression of being first author to last author, representing trainees publishing their work in the PI's laboratory. These are the challenges of assessing individuals, judging their performance for career advancement. And finally, readers deserve articles that are clear in every respect, including a sense of the relative contribution of each author, such as stated in JAMA in 1990. So there are some guidelines for determining the order of the authorship. It is first essential to decide who is an author and who is not. The requirements include being a laboratory or departmental sponsor, and last author are not mutually exclusive, but should depend upon the contribution, as we said. Can't always be enforced. The first author is that person who contributed most to the work, including writing the manuscript. Sequence of author listing is determined by relative contributions to the work. Second author should have contributed the second most substantial amount of work to it. The decision about authors and the order in which the names appear should be made as early as possible, even at the outset of the collaboration. This is what I was emphasizing before. Establish many of these working relationships very early on, such that you don't end up in trouble at the time of writing the paper and trying to decide whose name goes where. If you're only working with 3 or 4 people, it's not really a big deal, but if it gets up to 7, 8, 9, or 10, then it really can get messy. So although the relative contributions may need to be reassessed later by the group consensus, so it's the group consensus that counts. Each individual that makes a contribution feels that their contribution is substantial. So my data was critical, and without it, what kind of a publication are you going to have, and blah, 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 blah. So it can get pretty messy. So the disagreements about these matters should be resolved by the principals, not by the editor. So it should happen amongst the scientists, and that's what makes it a social ethics community type of an affair. However, editors can request documentation and writing of the author's specific contributions to the report. And as I said, we begin to see more and more of this as a requirement in the instructions to authors for journals. So a successful author must have impact at several levels. So the editor must be impressed enough by the submitted manuscript to publish it in the first place. Other authors must value the information contained in the article enough to cite it in their own writings. There are many standards for assessing these types of aspects of individual publications and journals. The Scientific Citation Index is where one would turn to find these. You begin now to see journals listing their impact factor. So you should look up the definition of that. There's a half-life for journals and a variety of other indices to assess them. And it becomes really quite important to understand the distinction between things like this. So the impact factor certainly is an assessment of the value of the information contained in the article enough to cite it in other reports by other groups. So the Scientific Citation Index is the one that indexes this, right? The half-life is an estimate of how long that paper is being referenced, so the longevity of its impact. So if it's published soon after it is, if it is cited soon after it's published, it obviously has impact, right? If it is only published once after it's initially, if it is only cited once, maybe 2 months after it has been originally published and never cited again, what kind of a longevity of impact is that? So the half-life evaluation becomes critical on that. So you should familiarize yourself with that information. It's not an exercise that I impose in this class, but you certainly, being responsible to yourself to understand these and how it impacts your own career and others' publications, you should familiarize yourself with that. We don't use them as the sole standard, but more and more people are using them as a primary standard to evaluate the quality of publications, the quality of journals, and the quality of the authors publishing those papers. So this is a very important aspect of successful authorship, and it really is one related to professional practice, but it is now becoming one of kind of the absurd approaches to assessing the success of journals as they compete for contributions, as they try to publicize themselves, and as individuals strive to gain advantages over other individuals to gather additional and vast and numerous resources. So it is something that came out of beneficence, principle of beneficence, and out of the principle of utility almost. It has gained almost more so in the harm that it can cause, because people get locked in on these things, and if you don't publish in journals that have at least this minimal impact factor, your research is worth no value whatsoever. So we all know that this indeed is not the case, but anyway, it is one of those controversial areas in the profession of science. And those who evaluate and promote the academic author must be of and value the publication as well. So there's ranking of journals as A journals and B journals. It's kind of absurd when you can just get on PubMed, do a search, and you pull up any paper whatsoever. And most of the time we read over the abstract to see if there's any value to the publication, and we go in and read the paper ourselves to assess whether it's worthwhile, regardless of the journal that it's published in. So describe the statistical methods with enough detail. We're reiterating this as well. So reinforcing these same concepts as we proceed. So this one makes a slightly different variant versus the others, with a reflection on your accountability. If you are required to turn over your original data, then someone should be able to compare your original data to the final presented data in the publication. So enable a knowledgeable reader with access to the original data to verify the reported results. So there's that accountability all the way to that level. So the statistical methods are extremely important, and we'll talk about statistical methods in this class. We'll actually present the formula and think our way through several statistical approaches that we are familiar with and some that we're unfamiliar with. Again, at the level of introduction and developing our familiarity with them, not so much our expertise. But we will develop a level of expertise on the utility of them. So when possible, quantify findings and present them with appropriate indicators of measurement error or uncertainty, such as confidence intervals. So here we're looking at, I should have looked at the title here, the statistical reporting of the article, so the reliability of the data. So the statistical methods should be appropriate. Anyone should be able to take your raw data and put it through the same statistical calculations and get the same results that you get. You have to have indices of variability. Confidence interval is not what we typically see. We typically see standard error of the mean or standard deviation. We'll talk about these in great detail and gain an appreciation for how they represent the raw data. So obviously if you have a very large standard deviation in your data set, then there's probably something wrong with your data set. Your experimental methods were not appropriate or controlled well enough, so immediately there might be a problem. Avoid sole reliance on statistical hypothesis testing, such as the use of p-values, which fails to convey important quantitative information. So in other words, there has to be more numerical values presented. It can be tabular. There's means for example, with the standard error of the mean that could be presented, the ranges of the data values could be reported, percent changes or these types of things, differences between this group and that group. So there's various ways of including numerical data in the report such that you're not just saying there was a statistically significant difference at a p-value of less than 0.05, so 95% probability that an error was not made. So discuss the eligibility of the experimental subjects, obvious for human subjects, even the animals as well. Give details about randomization, describe the methods for and success of any blinding observations, report treatment complications. So I know this is just a long list, but we're going to go through virtually each of these and study them in detail to understand their importance and why they should be listed under the guidelines for statistical reporting in the articles. Numbers of observations, so the number of animals in each group, the N value. Report the losses of observations, such as dropouts from the clinical trial. This is not always reported, so if you're doing cell culture and the cell culture becomes contaminated and you lose it, you discard it, you don't include it in the study, rarely do you ever see that reported in a publication. So what are the universalities of these? Do we always have to report that? References for the study design and statistical methods should be standard works with pages stated when possible rather than to papers where designs or methods were originally reported. So again, the responsibility of being accountable for the exact statistical method and its justification is extremely important. Specify any general use computer programs used, so that's key. Maybe even the versions of them, certainly the source of them. Put general descriptions of statistical methods in the methods section. When data are summarized, in the results section, specify the statistical methods used to analyze them. So there's certain ways of going about this so that you don't have a tremendous amount of redundancy. Remember, redundancy uses more space, and space is critical for publication. So these all have to be tempered in that context. If your article is too long, the editor will tell you it's too long and you have to shorten it. You go in and you start trimming, and what are the critical things that can be trimmed. So restrict the tables and figures to those needed to explain the argument of the paper and to assess its support. So too many tables and graphs also will raise a flag by the editor and the reviewers. Use graphs as an alternative to tables with many entries. Do not duplicate data in graphs and tables. So you don't put a table in and then have the graph of the exact same data. But you might have a graph with additional information in the results or discussion. So in the results you may give the range of values within a data set if it is going to contribute substantial understanding of the data set. And then in the discussion you may say this threefold or tenfold or 5% increase or decrease is important or significant in the sense that it compares, it's comparable to that reported by others, and so on and so forth. So there's ways of limiting the representation of the data, but giving similar impact. So you don't put your table for raw data in there. You don't put in a full table of data with all the means and standard errors of the means, and then provide line graphs for each. So there's reason in rationalization about this approach. It is certainly reasonable to expect this. And again, space is precious. So the editor and the publisher is not going to want you to have this extensive number of graphs, photographs, and tables. Avoid non-technical uses of technical terms in statistics, such as random, which implies a randomization device, normal, significant, correlation, and sample. We said you can't say this correlates to that unless you've done some type of a test for correlation. And then define statistical terms, abbreviations, and most symbols. If essential, these should be inherent. Again, this is from 1988, so it's been around for a long time. It's nothing new, and we don't present it as anything different. This concludes our discussion of the authorship, and I appreciate your time and attention today.